Okay, what we got here is a test of the math for the PID loop. The scope has the full 100 millisecond range. Currently, the plenum pressure is 697. The set point is 707, which is about 10 torr, and it varies a little, not 698, so it varies plus or minus 1, sometimes 2. The gain, the I is set to 0, the D is set to 0, the P is unity. So the error is 10 torr, so 10 torr times a gain of 1 is 10 milliseconds. So that's what we have. One division is 10 milliseconds. Okay, so now we are going to change the set point to 717, and the pulse width should go to, hit the wrong button. The pulse width should go to 20 milliseconds. 727 times a gain of 1 is 30 milliseconds, and it's pretty consistent. So let's go back to 707. It's quite interesting. We're on Boeing aircraft numbers, 707, etc. Okay, so now we're at 10 milliseconds. So now we are going to set the I gain to 1, which will automatically increase that pulse width until it's all the way phased on completely. There we go. Now we will go set I gain back to 0. And now we have 10 millisecond pulse again. The D gain isn't going to do anything because there's no rate of change in the pressure. So we can prove that by setting the D gain to 1, and I don't think anything will happen. No, nothing happens. Okay, so we're going to set the D gain back to 0. That's how the math works in the PID loop. So let's set the gain now to 2. So we're going to set the gain to 2, so our pulse width doubles. 2 times the error, which is we're 707 and we're 698 on the actual pressure from the transducer. So that's about 9. So your 2 times 9 is 18. You're at about 18 milliseconds. And you see it jumps a little more because the gain is 2. So 1 torr off and the gain will jump by 2 or 4 depending on that. Let's set the gain to 4. Set the gain to 4. And the 1 torr changes a lot more on the pulse width, so that when it's low here is when the valve is on. So we're varying between 697, 698, 697. It's varying in there about 1 torr. So that is how that math works. And as far as I can tell, the math is doing what the math is supposed to be doing for a traditional PID loop. So this kind of is, I'm trying to answer the questions on the engineering coordination memo regarding the PID loop. And the math's always been pretty much standard on PID loops for a long time, so there's nothing invented here. This is just textbook example stuff. And so I hope this explains some of what's going on. Okay.